is atom? Do you know what is atom?
Atom is a small.
Yes, it's a small particle. Yes, very good, Cecilia. Very good, sexy, Cecilia. So let's look at the answer. Atoms are very small particles with made matter, right? So we can say that it is fundamental unit. Okay? There are a lot of idea and model about atom. So I like to start with Democritus' idea. His idea about atom came up when he asked this question: if you break a piece of matter in half and then in half again, how many breaks will you have to make before you can break it no further? So, would anyone like to answer this question? I'll give you one extra point if you answer this question. Can we break the matter indefinitely?
Yeah,
Yes, is that okay? Let's have a look at Democritus' idea. He thought that it ended at some point, and a smallest possible bit of matter. He called this basic matter particle atom. Actually, he used the word atomos, Greek word that means untouchable. Democritus was a Greek philosopher who proposed that matter was made of tiny individual particles called atoms. And he believed that atoms were indivisible and indestructible. Okay, to Democritus, atoms were small, hard particles that were all made of the same material, but were different shapes and sizes. Atoms were infinite in number, always moving and capable of joining together. However, his approach was not based on scientific method. He also said that water or liquid have round and smooth atoms that can be easily slide over one another, and the iron atoms are hard and strong with hook that lock them into a solid. And this is an example of his assumption about the atom. He thought that sleep is caused by atoms escaping from the bed, and smell is caused by atoms interacting with the nose. And death is caused by too many atoms escaped and did not return. The heart is the center of anger. The brain is the center of thought. And the liver is the seat of desire. You think this is right? Yes, that's his own idea. So let's have a look at the real scientists. Let's start with John Dalton. Dalton proposed the modern atomic model at 1800. His model is based on experimentation, not based on pure reason. Dalton performed a number of experiments that eventually led to the acceptance of the idea about atom in 1803. He stated that atom cannot be created or destroyed. All matter, whether an element, a compound, or a mixture, is made up of a very tiny particles called atom. All atoms of a given element are identical in size, mass, and chemical properties. Yes, we understand. Okay. Dalton's postulate or matter is made of atom. The second postulate is atoms of an element are identical. The third postulate is each atom have different atoms. And the next postulate is atoms of different elements combined in constant ratios to form compound. And the last postulate is atoms are realigned in reactions. This idea also accounts for the law of conservation of mass. And Dalton's atomic model is known as Elliott-Bohr model. Okay. Question again. I'd like to ask you, are there particles that are smaller than atoms? Do you know?
No.
Do you know the particles that are smaller than atoms? So,
No.
yes. And no, this one is correct. Yes or no?
Yes.
Yes. Because we have a smaller particle, you know?
Right.
For example, electron, right? Yes, very good. Because now, so the answer of this question is yes or no?
Yes.
Yes. Because now we know that atom consists of three main particles, right? That are proton, neutron, and electron. Yes, very good. So let's move on to the next model, Thomson's model. Have you heard his name before?
Yes.
Okay. He is the first person who provided the first evidence that atoms are made of even smaller particles. He made up a piece of equipment. His equipment is called a cathode ray tube. Something like that. And this equipment consists of, I have this here, cathode, which is a negative, right? And anode, which is a positive. Okay. But passing an electric current makes a beam appear to move from the negative end to the positive end. By adding an electric field, the rays bend towards the positive pole, you know? Sorry. Yeah, the rays bend toward the positive pole, indicating that they are negatively charged, right? So they call these negatively charged the electrons. And this is the way that Thomson discovered the electron. So from the result of this experiment, he proposed his atomic model. His model is known as pudding model. He said that atoms were made from a positively charged substance with a negatively charged substance scattered about like plum or resin in a pudding. And this is the pudding model. So, we do know which fruit that can compare to the Thomson model. Which fruit do you think?
Watermelon.
Yes, very good, Ceci again. This model can be visualized as a watermelon. The whole watermelon is a positively charged, and the seeds are electrons. Okay. Now let's move on to the next model. Rutherford's model. His model is based on the experiment. His experiment setup consists of four main parts. The first part is this is a alpha particle source, and the next part is a thin gold foil. And the third part is the screen, which is a zinc sulfide screen. And the last part is not shown here. It is a microscope that put above the screen. fired the beam of alpha particle. Alpha particle is a positive particle. He fired a beam of alpha particle through the thin gold foil and observed the location at which alpha particle landed on the screen. And this is what Rajamangala observed. He found that most of alpha particles pass straight through the gold foil. This straight line. And some of particles get reflected in a small angle. And the last thing he found that a few particles get bounced off the foil and back to the left with a large deflection. From this result, he concluded that the atom is mainly empty space with a small area of positively charged. So, 97% pass through because they are meeting nothing. You see that? And those deflected are coming close to a positively charged. And those that bounce back are heading straight for the positive charge. And from this result of the experiment, he proposed his atomic model from the gold foil experiment. He said that atoms are mostly empty space and not filled with a positively charged material. So what Thomson said before is not true, right? And atoms have small positively charged at the center of them. And they have negatively charged particles orbiting, surrounding around the center of the atom. So, was his theory correct, you think? Yes or no? Yes. The answer is mostly. But Rajamangala he missed some information about neutron and electron and the location of electron. So now let's have a look. Bohr's model. His model is known as planetary model. He said that electrons move in definite orbits around the nucleus, much like planets circle the sun. Bohr found that electrons move in definite orbits or energy levels around the nucleus in 1913. Electrons orbit the nucleus in shells. Now, let's have a look. We move on to the current model. It's called electron cloud model. In this model, we cannot say with certainty where the electron actually at any point in time, yet can describe where it ought to be. This model is based upon Bohr's model, except that electrons orbit the nucleus in random pattern. The region where these particles are found is referred to as electron cloud. Okay, that brings me to the end of the lesson. Okay, I have an activity for you. I will give you a card, okay? And each of you will give one card with words on it. Just a student. Now you have to find another card that matches yours. You know? You have to find another card that matches yours. You know? Actually, I gave you a hint. In the card, I gave you a hint with numbers. Again. Then what you have to do is come in front of the class and explain the model you got. Okay? From information in the card. Electron cloud is just like that. Yes. I'll give you 2 minutes to complete your task.
Nucleus is positively charged.
Yes, it's the right I said explain it on digital science.
Yes.
No. I gave you a number. Okay, are you ready? Want to go first?
Is a going to?
No. You have to try a match number. This. 1, 2. Here we go.
Yeah, I can.
3. Yes, 3.
I can follow.
Yes. That's correct. 3 and 4. Anybody go? Be back. Three hands around. What is? Different of this around.
No.
Yeah, what's that? Electron module.
Oh, yeah.
Yeah. Okay, let's start. Let's see. Are you ready? You will see the front of the class and explain the model you got.
Yeah.
Ajani?
Yeah,
It's well.
it should be clear for Jeffy.
Okay, I got the electron module. Electron module, that means electron orbit around the nucleus, and we can write down. If we have the many crowd, it have many electron layers. Probability we have many electron layers. It's very good.
The electron is mostly of space, it's only of space, and in the center is a nucleus, right? It has positive charge on the center, right?
I have got function model of atom. Their model, this model can represent by the watermelon. The size of the atom is the size of the watermelon, and the positive particle in the atom in the atom is represented by the seed of the watermelon.
Good job. The size of electron not equal to the size of watermelon, right? It's very small. Okay, you will see. The last person. Welcome to
Okay, for the Negro model is about the electron orbit in the shell, and there are 7 shells that electron move around the nucleus that occupy with proton and neutron. That's okay?
Okay, you're all good job. For the next time we meet, I'm going to teach in topic quantum mechanics, and I'm going to talk about the question about this topic today. So please prepare before you come to class.